From humble beginnings, as simple toolmakers and hunters, humans have risen to become the most intelligent species on Earth. Our ability to reason, create, and adapt has led to the invention of tools, languages, cities, and entire civilizations. But have you ever wondered, why us? How did the human brain become the most powerful organ on the planet? Our brains are about 3 times the size of our closest relatives, the chimpanzees, but size alone doesn't explain why we're so much more advanced. The story of our intelligence is one of survival, social interaction, and evolution over millions of years. Let's start from the beginning. Around 3 million years ago, our ancestors were already walking upright, but their brains weren't much larger than a chimpanzee's. It wasn't until Homo habilis, also known as the handyman, appeared around 2 million years ago, that things began to change. This is the first species known to have made tools. Tool use wasn't just about survival. It forced early humans to think ahead, plan, and communicate with others. This likely sparked the early growth of brain regions responsible for problem solving and social interaction. But there was another game changer: fire. Homo erectus, who lived around 1.8 million years ago, was one of the first to control fire, and this may have been the tipping point in human brain evolution. Cooking food made it easier to digest and unlocked more calories. With more energy available, the human brain was able to grow, and this energy-hungry organ needed a lot of fuel. In fact, our brains use about 20% of our body's total energy, despite making up only 2% of our body weight. This energy boost allowed our ancestors to develop more complex behaviors, laying the groundwork for everything from hunting strategies to social cooperation. But it wasn't just the physical size of our brains that changed. The way we use them evolved too. Humans are incredibly social animals, and our ancestors found safety in numbers. Cooperation was key to survival. Living in groups required new skills, understanding others' intentions, forming alliances, and navigating complex social networks. The human brain evolved to handle these social challenges, leading to the growth of the prefrontal cortex, the region responsible for decision-making, empathy, and planning. As our ancestors interacted more, they needed better ways to communicate. The development of complex language was another leap forward, allowing us to share ideas, teach one another, and pass down knowledge. Fast forward to today, and we live in a world built by the brain, from skyscrapers to smartphones. We're surrounded by the fruits of human intelligence. But while our brains evolved to solve problems, they haven't fully adapted to the rapid changes of the modern world. Our brains evolved in small, tight-knit groups, not in cities of millions. The social and technological pressures we face today are far greater than anything our ancestors could have imagined. So where do we go from here? As we continue to evolve, will our brains grow even larger, or will we rely more on technology, merging with machines to enhance our intelligence? Some scientists believe that we've already entered a new phase of evolution, an era driven by technology. The rise of artificial intelligence, brain-computer interfaces, and genetic engineering could radically transform the human brain in ways that were once unimaginable. Imagine a future where we can upload our thoughts, enhance our memory, or even connect directly with other minds, all through the power of technology. But how far can we go before we stop being human? The idea of merging human brains with machines raises profound questions. As we unlock new ways to manipulate the brain, we're faced with complex moral dilemmas. What happens if we become too dependent on artificial intelligence? Could we lose our autonomy, our creativity, our human essence? And what about the future of genetic evolution? We're already developing technologies like CRISPR, allowing us to edit genes and potentially enhance human capabilities. But if we begin to design our brains choosing traits like intelligence, memory, or even emotional control, do we risk losing the diversity and unpredictability that made human evolution so dynamic? Then there's the possibility of extraterrestrial evolution. As we venture beyond Earth, into space, and onto other planets, how will our brains adapt to these new environments? Living in low-gravity environments or dealing with extreme cosmic radiation might force future generations of humans to evolve in ways we can't yet predict. The brain could develop new functions or even change structurally to meet the challenges of space colonization. But with all these advancements, perhaps the biggest question is not just how we'll evolve, but why? For millions of years, our brains evolved to solve problems, survive, and thrive in a changing world. Will the future of the human brain be driven by the same instincts? Or will our ability to control evolution change our motivations entirely? Some scientists speculate that in the distant future, we might not even need physical bodies anymore. Perhaps through advances in consciousness transfer, we'll find ways to exist as purely digital or energy-based beings, free from the limitations of biology and the human brain as we know it. It's a mind-bending concept, but it raises one final question. If we move beyond the human brain, will we still be human? The human brain has taken us from simple stone tools to the brink of interstellar travel. It's allowed us to create art, solve complex problems, and build societies that span the globe. And while our past evolution was shaped by nature, our future may be shaped by our own hands. One thing is certain, the journey of the human brain is far from over, and the mysteries of where it will lead us next are only beginning to unfold.